Two kinds of sequences are very important in mathematics: exponential sequences and arithmetic sequences, or linear sequences. And so we're going to look at what those sequences look like, how they behave, and how we can tell them apart. And then we'll do a third example where we consider what happens if it's neither of these. So in our first example, we have a series of numbers, which I've displayed as mixed numerals just so that the decimals don't look weird. And what we're going to show in this example is that this is an example of exponential growth. And for exponential growth, there has to be a common ratio. And to calculate the common ratio, what we're going to do is we're going to take one of the numbers and we're going to divide it by the previous value in the set. So we're going to start with the second one. We're going to take our 1/6 and we're going to divide it by 1/12. Fortunately for Excel, we don't have to worry about simplifying fractions, and we get a 2. Now, if we copy this formula or repeat it physically all the way down the list, if there is a common ratio, then the ratio that we get when we do this math should always be the same value. That's an example of exponential growth. Or an exponential sequence. Sometimes these are called geometric sequences. But the idea with a geometric sequence or an exponential growth sequence is that every time you have a value that you multiply by the same amount. So we could verify this by saying, okay, so if I take my 1/12 and I multiply it by the common ratio, I get the 1/6. Well, what if I take the 1/6 and I multiply it by the common ratio? I get 1/3. And so we can reproduce this sequence by taking the previous value, multiplying it by the common ratio, and then we get the new value all the way down the list. Now, for an arithmetic sequence, there is a common difference. And we calculate that by subtracting the values from each other. So we take the second value, we subtract the previous value, and in this case, we get 2.5. And if we repeat that, 16 minus 13.5, we get the same common difference. And if we go all the way down, every single time we subtract, we get the same value. So the common difference here is 2.5. And so what that tells us is this is an arithmetic or a linear sequence or linear growth. Each time we take another value in the sequence, it grows by a fixed amount. Now, the difference, if I calculate the difference in my first sequence, I'm not going to get the same value all the time. So if I take the difference, our second value minus our first value, and then I take my third value minus my second value, I'm not getting exactly the same value each time I take that difference. So this is not linear. If I take the ratios in my linear sequence, I don't get the same ratio each time. So 13.5 divided by 11, and then 16 divided by 13.5, I'm getting different values. And so that's telling me that this is not geometric. So linear sequences have a common difference. Take the subtraction between them, get the same value each time. In the geometric sequences, they have a common ratio. So we divide, and then we get the same value each time we divide. Now, if our sequence is neither of these, then they will both fail to have a common ratio or a common difference. So in this example, oopsie. Let me try again. In this example, if I take my 11 and I divide by 5, I get 2.2. But now if I take my 13 and I divide by 11, I don't get 2.2. And so if I keep doing this division all the way down, I can see that the ratio is going to vary each time. I'm not getting the same number over and over and over again. Sometimes they're similar, but they're not exactly the same. Same thing if I take my differences. If I say 11 minus 5, okay, so then what about 13 minus 11? Well, that's not the same thing. And so again, if I keep calculating the differences, sometimes I get the same number, but then sometimes I don't. And so again, this is not linear because it's no common difference. So essentially there's 3 kinds of sequences that you can have in this analysis. There's potentially geometric sequences, which have a common ratio. If I divide, I get the same number each time, dividing successive values in the sequence in the same order. So the later one divided by the former one, I always get the same number. That's geometric. Linear sequences are possible if I take the difference between them, which means I subtract. Again, typically the larger one minus the smaller one, the second one minus the first one, the third one minus the second one, etc. Then I should get the same difference. That's a linear progression. And then sometimes I just get some sort of random progression. Now, certainly there are other kinds of sequences, but these are the 3 main ones that we're going to worry about in this course.